Just traversal, what are the problems that people can ask in examination? Now, today we are just going to see that what exactly one more important questions that will be asked in GATE exam is spanning trees. Spanning, spanning tree. Now, what it is exactly spanning tree? Yesterday we started the discussion. So before we learn into spanning tree, we need to learn that what is a tree. Tree is tree is basically we already defined. Tree should be it is a acyclic. It should not form a cycles. That is the first point. And it should not form a cycle. That is the first point. And the second point we have already discussed. Every tree should be at least two vertices will have at least two vertices. Two vertices should have degree 1. This is a one more thing. And that means at least two vertices will have that is nothing but a basically tree. So, and also this is what a tree definition. Now, next coming to spanning tree. Spanning tree, if I want to say that it is what is a spanning tree, the basic condition is it should be a first tree. It is a should be a tree. It should be a tree. Then, and one more condition is that what is the condition we have discussed? What is the condition? It is a, what is the next one? It is a it is subgraph. It is a subgraph of a given graph. Spanning tree, when you find out just Samandi. For a graphs, we will find out the spanning trees. So it should be a subgraph of a given graph. Subgraph means, sir, subgraph means, you know how it is. Whether it is a subgraph means all the vertices should be present. That is a condition. Subgraph means what? In that all vertices. Clear ga? All vertices should be present. Should be present. Present. And coming to next one is all edges are mandatory? No, all edges are not. Only vertices are mandatory. Vertices are mandatory. But coming to edges is not required. So edges may be sub. Suppose if it is having like any 6 edges, maybe part of that. Okay. All vertices are mandatory, but all edges are not mandatory. All edges are not mandatory. Such a way that you have to construct the graph. So that is called a spanning tree. So, okay, now this is basically spanning tree. So example, already I have discussed in a previous class. Suppose if I have some graph, I have some graph. What are the possible spanning trees? We already discussed in the previous class. This is, let us take A, and this is, let us take B, let us take C, and let us take D. So all possible spanning trees. So maybe a condition that it should be a subgraph of the given graph. This is a given graph G having 4 vertices and 4 edges. Okay. So now the subgraph should be, the subgraph is like this. So this is also a subgraph and all vertices are present. A is present and all B is present and here C, D. The all vertices are mandatory. So this is the tree or not? This is absolutely, it is a tree because 2 vertices will have a degree 1 and it is not forming a cycle. That is satisfied. It is not forming a cycle. This is satisfied and at least 2 vertices will have a degree 1 satisfied and it is a subgraph of a given graph. You see this graph? It is a subgraph of the given graph. All vertices are present, but edges are not mandatory. Subgraph means, okay? So all vertices are should be present. This is also satisfied. And all edges are not mandatory. All edges are not mandatory. So this is what one of the possible spanning tree for this given graph. This is a given graph, and this is a one of the possible spanning tree. One of the possible spanning tree. Spanning tree. Like this for this graph, like this for this graph, we will have a different. See, this is a means I can take only these 3. That means I can skip this edge because if I add this edge, it is forming a cycle. So this should not happen. Okay. So let us take A and B and C and D. So there is a one more possible. And also there is a one more condition is there. So how many in some of examinations they will ask you that in GATE exam, how many possible spanning trees will be possible for the given graph. They will ask you how many possible spanning trees also. How many possible spanning trees. Okay. If anybody will have an idea, please try to share that how many possible spanning trees will be possible for this given graph. So like this. Like this is a one more possible, and also so this is one more possible spanning tree. This is one more possible. So let us take A, B, and what is this here? It is C and D. Here it is A, B, and C, D. So these all are different possible spanning trees for this given graph. These are the different possible spanning trees for this given graph. So you tell me, how can I decide, So can anyone just in general, can anyone tell me what is the in general formula? What is the general formula? Suppose this graph, ఇది one of the gate question అండి. Gate questions ఇలాగే అడుగుతారు. Just they don't know how to construct the spanning tree. They are just bothering its objective type, right? And they are not going to ask, fundamental concepts we have to learn, but they will not ask for fundamentals. Only few questions will be asked from the fundamentals. Then remaining questions will be based on applications. Now tell me, now we have what is the tree and what is the spanning tree, and these are all the possible spanning trees also. Now I want a general formula of that. I want a general formula of that. How many possible spanning trees for a given graph? Here it is having 4 vertices and 4 edges. 4 vertices and 4 edges. Can anyone tell me? So దీనికి ఆన్సర్ ఇప్పుడు మనం చెప్పేసాం కదా డైరెక్ట్ గా. సో ఫర్ దిస్ గ్రాఫ్ హౌ మెనీ పాసిబుల్ స్పానింగ్ ట్రీస్ ఆర్ దేర్? 4 possible, right? This is a one possible spanning tree, and this is a one more possible spanning tree, and this is a one more possible spanning tree, and this is a one more possible spanning trees. So for this given graph, I have drawn that 4 different possible spanning trees. Now in general, if they will give you some different graph, and you tell me how many possible different spanning trees will be possible for the given graph. దీనికి కొంచెం డిస్క్రీట్ మ్యాథమెటిక్స్ లో మనం నాలెడ్జ్ కూడా, ఫార్ములాస్ కూడా ఇంపార్టెంట్ అండి. సో నంబర్ ఆఫ్ ఎడ్జెస్ ఆర్ హౌ మెనీ అండి? చూడండి, ఎవరన్నా చాట్ బాక్స్ లో చెప్పొచ్చు ఆన్సర్. ఒకవేళ ట్రై చేస్తున్నారు అని తెలుస్తుంది అట్లీస్ట్ నాకు. మీరు కామ్గా ఉంటున్నారంటే యూనో అంత ఉపయోగం ఉండదు. ట్రై టు గివ్ ఆన్సర్స్. చాట్ బాక్స్ ఆన్సర్స్ ఇవ్వండి. ఎవరైనా ఇస్తారా ఆన్సర్స్? ట్రై చేయండి. ఇప్పుడు ఇక్కడ 4 పాసిబుల్ స్పానింగ్ ట్రీస్ ఆన్సర్ వచ్చింది. నాకేంటి అలా కాదు, జనరల్ ఫార్ములా చెప్పండి. హౌ వి గాట్ దిస్ 4 possible spanning trees. Now try to tell me what is the general formula. చెప్పాలండి ఆన్సర్స్. రాంగ్ అయినా పర్లేదు, ట్రై చేయాలి. Okay, I will tell you, don't worry. So in general, you try to remember whenever any gate exam or any competitive examinations they are asking, total number of edges in the tree are how many? అదన్నా చెప్పండి కనీసం. What is the total number of edges in this graph? Total number of edges how many అండి? ఈ గ్రాఫ్ లో how many edges are there? 4 edges. Very good. So number of edges are operation. Okay, ఇలా రాయాలి ఎప్పుడైనా. Number of edges ఇలా రాస్తారండి. Modulus of E equal to 4. And number of vertices are how many అండి? Number of vertices also 4. This is what? Okay, number of vertices are 4. Now in general, that means in general, how many, you see that in this spanning tree how many edges are there అండి? Only 3 edges. So in this spanning tree also how many edges are there అండి? 3 edges. In this spanning tree also, how many edges are there? 3 edges. In this spanning tree also, how many edges are there? 3 edges. Now, in general, so can I say here, our possible spanning tree is, if it is having 4 vertices, now 3 edges, that is number of vertices minus 1. ఎన్ని edges ఉన్నాయంటే spanning tree లో number of edges in the spanning tree is always, you try to remember, always number of is equal to number of vertices minus 1. Number of vertices minus 1 is spanning tree లో. So number of vertices, గుర్తుపెట్టుకోండి ఎప్పుడైనా, number of vertices minus 1. Okay. So that means, ఇప్పటికన్నా చెప్పండి ఎవరన్నా, నేను ఆల్రెడీ క్లూ కూడా ఇచ్చేసాను, నంబర్ ఆఫ్ వర్డ్సెస్ minus 1. So that means out of 4 spanning trees, out of 4 edges, so out of 4 edges, ఈ ఫార్ములా కదండి, out of 4 edges, we need to connect any three edges. That's it. 4C3 is equal to ఏమండి? 4C3 వాల్యూ ఏమైంది? Can I say 4C1? అందుకే కొంచెం మ్యాథమెటికల్ నాలెడ్జ్ అవసరం అండి డాకింగ్ కూడా. 4C1 గేట్ ప్రాబ్లమ్ సాల్వ్ చేయాలంటే కొంచెం డిస్క్రీట్ మ్యాథమెటిక్స్ నాలెడ్జ్ అవసరం ఉంటుంది. సో 4C3 ఈక్వల్ టు 4C1, అవునా కదండి? 4C3 ఈజ్ ఈక్వల్ టు 4C1. సో వాట్ ఇస్ ద 4C1 వాల్యూ? 4C1 వాల్యూ ఎంత? 4 కదా. ఆన్సర్స్ ఎంత? వాట్ ఇస్ ద 4C1? C1 అంటే 4 నండి. 4C1 ఈక్వల్ టు 4. కావాలంటే రాయండి. వాట్ ఇస్ ద ఫార్ములా ఆఫ్ ఎన్సిఆర్? ఎన్సిఆర్ ఫార్ములా ఏందండి? ఎన్సిఆర్ ఈక్వల్ టు n ఫ్యాక్టోరియల్ బై n మైనస్ r ఫ్యాక్టోరియల్ ఇంటూ n minus r factorial into factorial. సో ఇక్కడ n factorial into 4C1. 4C1 అంటే 4 factorial by 4 minus 1 factorial, 3 factorial into 1 factorial. సో ఇక్కడ 3 factorial అంటే 4 into 3 factorial, 3 factorial, 3 factorial will cancel. తెలుసు కదండి. ఏంటో ఆన్సర్ కూడా చెప్పట్లేదు. 4C3 ఫార్ములా కూడా 4 factorial by here 3 factorial into 1 factorial. 4 factorial అంటే ఎంత అండి? 4 factorial అంటే 4 into ఇలా రాయొచ్చా? 4 into 3 factorial 4 into 3 factorial, or you can say 4 into 3 into 2 into 1 divided by 3 factorial. 3 factorial అంటే ఇంత వాల్యూస్ అవుతుంది. 3 factorial into 2 factorial into 1. ఎంత ఆన్సర్? 4 కదా. So like this you have to solve. This 3 cancel and this 3 to 1 cancel. Answer is 4. That's why we got 4 different spanning trees. So ఎప్పుడైనా గుర్తుపెట్టుకోండి, in general, so this is 4 is nothing but number of edges C into 4 అంటే ఇక్కడ number of edges E, రాసుకోండి ఫార్ములా, E C number of vertices minus 1. నంబర్ ఆఫ్ వర్సెస్ మైనస్ 1 అండి. ఇది ఫార్ములా. ఇది సింపుల్ గా ఒక సైకిల్ ఉంది కాబట్టి ఓకేనా. దిస్ ఇస్ వన్, జస్ట్ ఓన్లీ వీఆర్ హ్యావింగ్ వన్ సైకిల్. సపోజ్ ఏమైనా ఎక్స్ట్రా ఎడ్జెస్ ఉన్నాయి అనుకోండి అండి. సపోజ్ ఇఫ్ ఇట్ ఈస్ హ్యావింగ్ మోర్ దెన్ లైక్ దిస్ ఎడ్జ్. ఇప్పుడు ఇది సింపుల్ గ్రాఫ్ కాబట్టి ఇలా ఉంది. సో ఎప్పుడైనా దీనికి ఇంకొంచెం అడ్వాన్స్ వెళ్దాం. దీనికి అడ్వాన్స్డ్గా సపోజ్ ఇఫ్ ఐఎమ్ యాడింగ్ వన్ మోర్ ఎడ్జ్ లైక్ దిస్. ఈ గ్రాఫ్కి వీఆర్ యాడింగ్ one more edge. Now in this graph, you see here, it is not 4. It is not 4. So you will get more, extra more. So number of edges are how many? Up to 5 into one more condition ఇక్కడ. ఇలా ఎప్పుడైతే గ్రాఫ్ మోర్ దాన్ 2 సైకిల్స్ ఉంటాయో అప్పుడు వేరే ఉంటుందండి ఫార్ములా. సో సేమ్ నంబర్ ఆఫ్ ఎడ్జెస్ సి నంబర్ ఆఫ్ వర్సెస్ -1. ఒకవేళ సైకిల్స్ అనేవి ఇక్కడ ఎన్ని ఉన్నాయి చూడండి. 2 cycles are there. That means this is a one cycle and this is a one more cycle. So 2 cycles ఉన్నాయంటే we can have to subtract -2. We have to subtract -2. So అప్పుడు ఏంటంటే number of edges are how many? 5 5C3 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 -2. 5C3 -2 అండి. 5C3 -2 అలా ఉంటుంది. ఓకే, ఐ హోప్ యూ అండర్స్టాండ్. సో దిస్ ఈస్ ఈ ఫార్ములా ఓన్లీ, ఈ ఒక్క ఫార్ములా ఓన్లీ ఫర్ ద సింపుల్ గ్రాఫ్, like a simple like this graph. But if it is having more than like this cycle, in this graph I have a one cycle like this. Whenever you have a more than 2 cycles, then the formula will be number of edges C number of vertices -1, and this is after subtract how many cycles are there. How many cycles are there in this graph? 2 cycles are there. ఇది గేట్ లో అడిగే క్వశ్చన్ అండి, గ్యారంటీగా అడుగుతాడు క్వశ్చన్. దట్స్ వై ఐఎమ్ స్ట్రెస్సింగ్ మోర్ ఆన్ హియర్. సో రాసుకోండి, ఇంతవరకు రాసుకోండి. 2 అంటే ఏందండి ఇక్కడ? 2 అంటే ఏందో రాసుకోండి క్లియర్గా. వాట్ ఈస్ నంబర్ ఆఫ్ సైకిల్స్? 2 ఈజ్ నథింగ్ బట్ నంబర్ ఆఫ్ సైకిల్స్ ఇన్ ద గ్రాఫ్. నంబర్ ఆఫ్ సైకిల్స్ అంటే చూడండి, ఏ బి డి, దిస్ ఇస్ వన్ సైకిల్, అండ్ వన్ మోర్ సైకిల్ ఈస్ బి సి బి. ఓకే, అంటే ఇక్కడ మళ్ళా ఇది ఫుల్ ఏబిసిడి కూడా సైకిలే, కానీ అంటే గ్రాఫ్లో టోటల్ గ్రాఫ్లో సబ్ సబ్ గ్రాఫ్స్ లో ఉన్న సైకిల్స్. ఓకే, సో దిస్ ఇస్ a one cycle and this is a one more cycle. That is why we are subtracting 2. So 5C3 minus 5C2 minus 2. 5C3 or we can say 5C2, anything. 5C3 is equal to 5C2 only. So what is the 5C2 value? Only చేయాలి, చెప్పండి అండి కనీసం. వాట్ ఇస్ ద 5C2? వాట్ ఇస్ ద ఆన్సర్? 5C2 minus 2 చెప్పండి అండి, కొంచెం ఆన్సర్ చెప్పండి. ఫర్ దిస్ గ్రాఫ్ వాట్ ఆర్ ద టోటల్ నెంబర్ ఆఫ్ spanning trees possible? Total number of spanning trees will be possible. చెప్పండి ఎవరైనా చేసి. ఆన్సర్ ఇస్ 5C2 minus 2. ఆన్సర్ చెప్పండి ఎవరన్నా. 5C2 minus 2 చెప్తారా, నేను చేయాలా మళ్ళా? ఎన్ని స్పానింగ్ ట్రీస్ పాసిబుల్? Good. 5C2, 5 factorial, 5 into 3 into, so 5 into 4 into 3 into 2 into 1. ఏంటండిలా by what is n minus r factorial? 5 minus 2 అంటే 3 factorial into what is r factorial? 2 factorial అంటే ఈ 3 factorial cancel. Here 2 into 2. So what is the answer? 5C2 value 10. 5 into 2, it's a value 10. 10 minus 5C2 minus 2 కదండి, అంటే 5C3 ఈజ్ ఈక్వల్ టు 5C2 అండి. సో అది మ్యాథమెటిక్స్లో ఉంటుంది మీకు, డిస్క్రీట్ మ్యాథమెటిక్స్లో. సో 10 minus 2, so it's a 8. Total, how many different spanning trees possible for this graph? Total number of possible spanning trees are 8 for this graph. Okay. Like this, I will construct one more graph. Now tell me. So this is, I am drawing one more graph. You try to tell me. Let's take this graph and ఆన్సర్స్ చెప్పాలండి ఈ గ్రాఫ్కి. So let us take vertices A, what's the small letters? A, B, and C, and D, and E, and F. Tell me. Total number of total number of possible spanning trees. Total number of possible spanning trees. Spanning trees for the given graph. For the given graph. చెప్పండి. ఆప్షన్స్ ఆన్సర్ చెప్పండి డైరెక్ట్గా, ఆప్షన్స్ ఏముంది కానీ ఆప్షన్స్ ఐ విల్ గివ్ యూ ఎనీహౌ. మీరు చెప్పండి ఆన్సర్స్ ఫర్ దిస్. టోటల్ నంబర్ ఆఫ్ పాసిబుల్ స్పానింగ్ ట్రీస్ ఫర్ ది గివెన్ గ్రాఫ్. ఎవరైనా చెప్పండి ఆన్సర్లు. I will give you 1 minute. Please try to work out and tell me. 1 or 2 minutes. వర్కౌట్ చేయండి నేను చెప్పిన ఫార్ములా. టోటల్ నంబర్ ఆఫ్ ఎడ్జెస్ ఎన్ని ఉన్నాయండి in this graph? In this entire graph, total number of edges are how many? 7. And total number of vertices are how many? 6. And total number of cycles are how many? Total number of cycles 2. Very good. So values అన్ని డైరెక్ట్ సబ్స్టిట్యూట్ చేయడమే కదా. ఏంటి ఫార్ములా? నంబర్ ఆఫ్ number of total number of edges are edges equal to 7 and number of vertices are vertices is equal to 6 and number of cycles equal to 2 cycles. This is a one cycle, right? This is a one cycle and the cycle length should be less than the 6 అండి. Okay, ఇవన్నీ less than 6 కదా. Yes. And this is also one cycle. So total number of cycles are 2. So now I have already given the formula. What is the formula? Formula ఏంటండి? Number of edges number of edges C number of vertices minus 1 number of vertices minus 1 and out of total minus 2 total minus 2. This is a formula. ఇంకొంచెం షార్ట్లో రాస్తా C vertices minus 1 here out of total minus how many cycles are there? 2 cycles. This is formula. Substitute చేయండి అన్ని వాల్యూస్ తెలుసు కదా. What is the value? 7. E value is 7 and C and number of vertices are how many? 6. 6 minus 1 5. 7C5 7C5 is equal to 7C2 అండి. తెలుసా ఇది? NCR equal to NCN minus R. ఆ ఫార్ములా తెలుసా? NCR equal to NCN minus R అని. So 7C5 equal to what? 7C2. So 7C2 అంటే now 7C2 minus అంటే సింప్లిఫికేషన్ ఈజీగా ఉండడం కోసం అంతే. లేదా 7C5 అయినా చేయండి, నో ప్రాబ్లం. సో 7C5 అంటే కొంచెం మీరు అనవసరంగా లెంతీగా చూసుకోవాలి కదా, అందుకు 7C5 అయినా చేసుకోండి, నో ఇష్యూ. ఓకే, 7C5 అయినా చేయండి, 7C2 రెండు కరెక్ట్ సేమ్ ఆన్సర్లే వస్తాయి. 7C2 minus 2 ఎంతండి? 7C2 వాల్యూ చెయ్యాలి మీరు. ఆల్రెడీ చెప్పా కదా, ఎన్సిఆర్ ఫామ్ లో కూడా చెప్పాను. చెప్పండి ఆన్సర్స్. టోటల్ ఆన్సర్ ఎంతండి? 21 NC2 7C2 సో ఏంటి? 7 ఫ్యాక్టోరియల్ బై 7 minus 2 అంటే 5 ఫ్యాక్టోరియల్ ఇంటూ 2 ఫ్యాక్టోరియల్ అంతే కదండి. 5 ఫ్యాక్టోరియల్ ఇంటూ 2 ఫ్యాక్టోరియల్. సో 7 ఫ్యాక్టోరియల్ అంటే 6 5 7 into 6 into 6 into 5 factorial 5 factorial cancel 2 అంటే 2 3 is very good 21 7C2 value equal to 21 minus 2 21 minus 2. So total number of spanning trees are 19. Very good. Total number of spanning trees possible is 19. So this is what answer. Very good, ma. So those who are giving answers, so I will appreciate you. So you have to give the answers. Direct formula చెప్పి ఆన్సర్స్ కూడా ఇవ్వకపోతే ఎలా అండి? ఒక బుక్ ఒక పెన్ ఉండాలి. మీరు ఓన్లీ జస్ట్ మొబైల్స్లోనో లేకుంటే ఓన్లీ అలా పెట్టుకొని వినడం వల్ల ఉపయోగం ఏమి ఉండదు మీకు. జస్ట్ ఏదో టైంపాస్. ఏదైనా నేర్చుకోవాలి అంటే బుక్ పెట్టుకొని రాసుకుంటూ చెప్పింది రాసుకుంటూ మీరు కమ్యూనికేట్ నేను అడిగిన ఉంటారు. లేదు అంటే జస్ట్ ఏదో టైం పాస్కి 2 hours అని ఊరికి అట్లా ఆన్ చేసి కూర్చోవటం అంటే అది కరెక్ట్ కాదు. ఓకేనా? చెప్పిన వాటికి ఆన్సర్స్ ఇవ్వాలి. చాలా తక్కువ మంది ఇస్తున్నారు ఆన్సర్స్. సో దిస్ ఈస్ వాట్ స్పానింగ్ ట్రీస్. దీస్ ఆర్ ద డిఫరెంట్ పాసిబుల్ స్పానింగ్ ట్రీస్. కానీ ఇప్పుడు మనకు కావాల్సింది ఏంటంటే నౌ విన్ దిస్ వన్ ఐ హోప్ ఇట్ ఈస్ అండర్స్టాండ్. ఓకే, ఇంకెంతకంటే దీన్ని ఐ డోంట్ వాంట్ టు స్పెండ్ మోర్ టైమ్ ఫర్ దిస్. నౌ ఐఎమ్ గోయింగ్ ఫర్ ది నెక్స్ట్. అవుట్ ఆఫ్ దిస్ 19 స్పానింగ్ ట్రీస్, ఓకే, సో I want to know that which one is best spanning tree. So because 19 spanning trees possible అంటున్నాం, 19 spanning trees కంటే I need to know that what is the minimum cost spanning tree అంట. ఓకే, so I want only find out the minimum cost spanning tree. So minimum cost spanning trees. So now next one is, in this spanning trees we have a minimum cost spanning tree. Minimum cost spanning tree. ఇప్పుడు నేను చెప్పిన మోడల్ మీద నాకు తెలిసి చాలా ఇయర్స్ ఆ క్వశ్చన్స్ అడిగారండి. వాట్ ఆర్ ద టోటల్ నెంబర్ ఆఫ్ పాసిబుల్ స్పానింగ్ ట్రీస్ ఫర్ ది గివెన్ గ్రాఫ్. సో అది మీకు చాలా ఉపయోగపడుతుంది. సో మినిమం కాస్ట్ స్పానింగ్ ట్రీ, మినిమం కాస్ట్ స్పానింగ్ tree. So that means what is minimum cost spanning tree means, now we have just find out, no, for the given graph we have a different uh, possible spanning trees will be different spanning trees will be possible. So now out of that given possible spanning trees, I want to find out minimum cost spanning tree. I want to find out minimum cost. Okay, minimum cost. That means, so when we are going for the minimum cost means you have to take the weights of the graph. You have to take the weights of the graphs. So weights of the graphs. So let us see that. So in order to find out minimum cost spanning trees, for this we have again 2 algorithms are there. To we have a 2 algorithms are there, and in this we have a first algorithm is, చెప్పండి మీకు తెలుసుండొచ్చు కొంతమందికి. So what is the first algorithm is? First algorithm is, what are the different minimum cost spanning trees? తెలుసా? తెలిస్తే చెప్పాలి ఒకవేళ. Okay, anyway, I will tell you. So we have a Prim's algorithm, Prim's algorithm, Prim's algorithm, and next Kruskals algorithm. Kruskals algorithm. Kruskals algorithm. Okay. So these are the 2 different spanning trees. What is the purpose of Prim's and Kruskals algorithm? చెప్పండి. Why we need these 2 algorithms? To find out minimum cost spanning tree. To find out minimum cost spanning trees. So I will give you one graph. For that maybe for the given graph, maybe different spanning trees will possible, but I don't want all that spanning trees. I just want to find out only minimum cost. I want to find out only minimum cost spanning tree. So now what should I do for that? So let us take one simple graph. Let us take one simple graph. So I'm drawing a simple graph. Let me explain this problem. I'm going to explain two algorithms. Now you see here. This is also a possible question from the gate. Actually, they will give you, uh, but if they will give like this type of problem, it will be somewhat easy, I can say. Okay. If they will give you just a minimum cost span tree, but this is also they have asked for it. And later we will work out for this. No, we are going to work out for time complexities also. That is also people will ask in exam. So let us take, we have A, B, C, A, B, C, D, and E. Now we have a weights also, right? We are having weights. Let us take weight 2 and 3, and let us take 5, and let us take 4, and let us take 3, and let us take 4. Some random weights you can take, okay? Or instead of 4, you can take some more weight. Okay, 6. Okay. Now, so now minimum cost pantry. Now we will take the different weights instead. Same weights also, it will be, you can take no issue. That's not it. The spanning tree will have a same in different places, need not different weights. Maybe it can be repeated also. That's not an issue. So now tell me, first, graph, you tell me. So which is having, what are the different possible spanning trees? Anyway, I am not going to bother about now. Now try to calculate the how many possible spanning trees will be possible. So you work out with the formula and you tell me later. But now I am focusing on how to find out how to use the Prim's algorithm and how to use Kruskal's algorithm. Now, first we will try to go for the Prim's algorithm. First, Prim's algorithm. What is the Prim's algorithm and how we can find out the minimum cost spanning tree? So let us take all the vertices first. Let us take all the vertices. So how many vertices are there? A here and B, A, B, and here we have a E and E, D, and we have a C. These are all the vertices anyway. Anyhow, I need to take. Okay. Now, first, always start with the minimum weight edge. What is the minimum weight edge? Cheppandi, out of the given graph, what is the minimum weight? Weight and ఏంటి? For this edge, weight is 2. For this edge, weight is 3. For this edge, weight is 5. For this edge, weight is 4. For this edge, weight is 8. For this edge, weight is 6. Like this, you tell me what are the minimum weight in this given graph. చెప్పండి ఈ మొత్తం గ్రాఫ్ what is the minimum weight A to B, very good. So that is AB edge. So that is this edge is a minimum weight. Start with the minimum weight edge and the cost is 2. Cost is 2. And out of this connected graph only. So what is the least one? What is the least one? So that means from A to E we have a 3 and B to D we have a 4. Which one is the least? So A to E is the least one. So I can connect with the 3. I can connect with the 3. So this is a one more possible weight. And after that, you see here, after this from B to D, I have a 4 and I have a this entire connected path. From this entire connected path onwards, I have to connect. Okay. So from B to D, I have a 4. From U to D, 5. Like this, it is there. Which one I need to select? Next to 4. So I have to select with the B to D. So this is the cost is 4. And next least cost it. So 5 can I connect? 5 can I connect? If I connect that 5, what it is? It is forming a cycle. It is forming a cycle. So this I cannot connect. This I cannot connect. So next, what is the choice I have? Either I need to connect from the B to C or D to C. So which out of these two things, which one is the least? D to C is the least one. So this is the cost is what? 6. Now can I connect this B to C? No, I cannot connect B to C because it will form a cycle. So now you check here. So this is a minimum cost spanning tree, and a spanning tree also you check the conditions. Total number of vertices are how many? 6 vertices are there. So total number of edges are total number of vertices are 5 only. So total number of edges are how many? 5 minus 1, 4. Check చేయండి చూడండి 1 2 3 4. ఏ స్పానింగ్ ట్రీలోనైనా ఎన్ని ఎడ్జెస్ ఉండాలండి? Total number of vertices minus 1. Total number of vertices minus 1. So you see total number of vertices minus 1. And all vertices should be present. Any vertices ఉన్నాయి? All the 5 vertices are there and all 5 vertices should be present. So this is tree by using what? Prim's algorithm. By using Prim's algorithm. థియరీ ఎగ్జామ్ కంటే ఏం చేయాలండి? దీన్ని స్టెప్ బై స్టెప్ రాయాలండి. అది వేరే. ఐఎమ్ జస్ట్ కాన్సన్ట్రేటింగ్ ఆన్ ఓన్లీ గేట్ పాయింట్ ఆఫ్ వ్యూ. ఓకే. సో లైక్ దిస్ యూ కెన్ కాస్ట్. అండ్ వాట్ ఈస్ ద మినిమం కాస్ట్ అండి? క్యాలిక్యులేట్ చేయండి. మినిమం కాస్ట్ ఎంత? 3 plus 2 plus 3 plus 2 plus 4 plus 6. What is the minimum cost? 15. 15 is a minimum cost by using the minimum cost spanning tree by using the Prim's algorithm. By using the Prim's algorithm. రాసుకోవాలండి. By using Prim's algorithm. Next we will go for the, this is what Prim's algorithm. Next, try to work out for the, like this, it will be asked in GATE exam also, they don't have any choice. If they want to ask a minimum cost spanning tree, so they have to give one graph and they have to ask what is a minimum cost spanning trees. Not only multiple choice type questions, like we have some questions like direct fill in the blank. So that is also possible because they will not give multiple choice. They will give you just what is the minimum cost spanning tree for the given graph. You need to enter directly 15. You don't have any options also. For that type of questions, this is possible. And let me explain you Kruskal's algorithm. Next one is Kruskal's algorithm. So let me explain the Kruskal's algorithm and just okay. Let me take one more graph. For that same graph also you can take no issue, but I will take some different graph so that you can understand the importance of algorithm. Kruskal's algorithm. Kruskal's algorithm. In this Kruskal's algorithm, what we will see is we are going to work out with the, we have a graph like this. And like this. And I have some more like this. I'm adding. Let me give you here 4, here 1, here 7, 8. Okay. So you see here. Now this is a given weighted graph. Okay. For this also we'll give one more weight. Uh, let me do. So these are the weights. The vertices. Vertices A, B, and C, and D, and E. These are the vertices are there and edges are there. Now I need to connect. You see here, I need to connect here. So try to draw all the vertices. Okay, all the vertices. A, B, here we have E, and here we have D and C. Let me draw the graph. Now, according to Kruskal's algorithm, here, wherever the least cost stage, try to select that least cost stage first. What is the least cost stage, Andy? Out of all this given graph, what's the least cost stage? Here, right? B to C. So you try to select the least cost stage is B to C. And In this, what is the cost of this one? Okay, I will add cost later. Okay, B2C is the one. And next least cost edge is what? Next least cost. Previous, according to Prim's algorithm, we need to see only from the this connected path. But according to Kruskal's algorithm, you can collect, you can take from anywhere. You can take from anywhere. Connectivity is not required. But whereas in a Prim's algorithm, only either you need to connect from the C to D or you need to connect from the this view only. But for this problem, I don't have any restriction. I can directly, wherever the least cost edge is there, I can directly. So A to E, I can connect. And the next least cost edge. So the connection is not, we are not bothering about it. Okay. That is why this Kruskal's algorithm can be applied on an disconnected graph also. Prim's algorithm can be applied for the only connected graph. But whereas a Kruskal's algorithm can be the ఈ పాయింట్ కూడా అడుగుతారండి గేట్ లో. Kruskal's algorithm can be applied for disconnected graph also. Disconnected graph also. Whereas Prim's algorithm can be applied only for the connected graph. That point also important. So next, now tell me here, A to E is added and next least cost edge is 3. Yes or no? 3 kada? Next last 3. This is added. And what is the next least cost edge? Next least cost edge is 2 done, 3 done, next 1 is done. Next least cost edge is A to B. So 4. And least cost edge and 5. Can I add 5? No, it is forming a cycle. Okay, next least cost edge is 7. 7. Can I add this one? No, it is forming a cycle. So next least cost edge, if I want to have a 8. Can I add this 8? No. So this is what possible spanning tree. Now what are the weights? Cost of the, here it is 1 and here it is 4 and here it is 2 and here it is 3. So total cost is 10. Total cost is 10. Very good. So total cost of is 10. 1 plus 4, 5, 5 plus 2, 7, 7 plus 3, 10. And total number of edges in this spanning tree, you check here. మనం అన్ని కండిషన్స్ సాటిస్ఫై అయితే లేవు కూడా చూడండి ఒకసారి. సో టోటల్ నంబర్ ఆఫ్ edges are how many? Number of vertices minus 1. Total number of vertices are how many here? 5 minus 1. So 4 edges. 4 edges. It is satisfying. It is not forming a cycle. And it is a tree also. That is, at least 2 vertices will have a degree 1. So this is all satisfied, right? So, Kruskal's algorithm. Kruskal's algorithm. Prim's algorithm as well as Kruskal's algorithm. Kruskal's algorithm. So like this, you can try to work out in the gate. So it is no, we don't have any difficult problems in this. We will have very basic problems only. I hope. So this is something about graph traversals as well as minimum cost spanning trees. Minimum cost spanning trees. ఎగ్జామ్ లో మనం టైం చాలా ఇంపార్టెంట్ అండి. సో ఫస్ట్ ఫస్ట్ అటెంప్ట్ లో ఈజీగా వచ్చిన ప్రాబ్లమ్స్ అన్ని ఫస్ట్ చేసేయాలి. లేకపోతే ఏదైనా ఒక ప్రాబ్లం దగ్గరే స్ట్రక్ అయ్యారనుకోండి, అదే ఎక్కువ టైం తీసుకుంటుంది. ఫస్ట్ ఈజీగా ఉన్న ప్రాబ్లమ్స్ అన్ని ఫస్ట్ రౌండ్ లో చేసేయాలి. సెకండ్ రౌండ్ లో ఇంకొంచెం ఒక 1 or 2 minutes ప్రాబ్లమ్ సాల్వ్ చేస్తే వస్తుంది అన్న ప్రాబ్లం దగ్గర స్పెండ్ చేయాలి. అట్లా థర్డ్ రౌండ్ లో ఇంకొంచెం డిఫికల్ట్ ప్రాబ్లమ్స్ ఉన్నాయనుకోండి, లేదంటే ఏమవుతుందంటే ఒక్కోసారి టైం సరిపోక ఈజీగా ఉన్న ప్రాబ్లమ్స్ కూడా అటెంప్ట్ చేయలేరు. సో అందుకని ఒక్కసారి అన్ని సబ్జెక్టుల్లో ఈజీగా ఉన్న ప్రాబ్లమ్స్ అన్ని ఫస్ట్ డ్యామ్ షూర్ అని పెట్టేసేయాలి. ఓకే, సో నౌ లెట్ మీ ఎక్స్ప్లెయిన్ సమ్ మోర్ కాన్సెప్ట్స్. ఫస్ట్ మనకి అల్గారిథంలో మోస్ట్ ఇంపార్టెంట్ థింగ్ ఈస్ టైం కాంప్లెక్సిటీస్ లో ఫర్ ఎవ్రీ ప్రాబ్లం. ఓకే, to explain the time complexities for all the problems. ఇంకా నెక్స్ట్ ప్రయారిటీ వచ్చేసరికండి డా సబ్జెక్ట్ లో, ఈ అల్గారిథం సబ్జెక్ట్ లో హైయెస్ట్ ప్రయారిటీ క్వశ్చన్స్ వచ్చేసరికి హైయెస్ట్ ప్రయారిటీ నేను మీకు ఎక్కువ గేట్ వరకు ఏటిల్లో అడిగే ఛాన్సెస్ ఎక్కువ ఉన్నాయి. వాటి మీద ఐఎమ్ కాన్సన్ట్రేటింగ్ ఆన్ మోర్ ఆన్ దట్. సో దట్ ఈస్ మై ప్రైమరీ ఫోకస్. And also definitely for any interviews are also is a very no it is important subject that algorithms are. Because this is a way of problem solving techniques, and also we are designing the problem and we are analyzing the time complexities also. Okay, in order to analyze the time complexities for any given problem, బేసికల్గా ఈ సబ్జెక్ట్ యొక్క మెయిన్ మోటివేట్ అండి, ఏదైనా ఒక ప్రాబ్లం చేసుకోవాలి. ఓకే, ప్రాబ్లం స్టేట్మెంట్ అండ్ ఆ ప్రాబ్లం స్టేట్మెంట్ని డిజైనింగ్. సో డిజైన్ ఆఫ్ అల్గారిథం డిజైన్ చేయాలి. మనం ఆల్రెడీ స్టార్టింగ్లో కూడా చెప్పుకున్నాం. సో అల్గారిథం డిజైన్ చేయాలి. అల్గారిథం డిజైన్ చేసిన తర్వాత నెక్స్ట్ వాట్ వీ హ్యావ్ టు డూ ఆఫ్టర్ డిజైనింగ్ అల్గారిథం? సో designing algorithm, problem statement, and we are designing algorithm, and by using algorithm we need to solve the problems also. That means implementation fairly. Next one is last law. After implementation we is there. Okay, so this is the thing. So and we have a one more step is analysis. In the analysis phase మనం ఆల్రెడీ చెప్పుకున్నాం ప్రియారి, పోస్ట్ ప్రియారి అనాలిసిస్ అని స్టార్టింగ్ క్లాస్లోనే. ఓకే, ఈ అనాలిసిస్ లో బెస్ట్ మనకి ఏంటంటే ఫస్ట్ చాలా ఏ ప్రాబ్లంకైనా మనకి ఫస్ట్ అనలైజ్ చేయాల్సింది వీ హ్యావ్ ఏ టైం కాంప్లెక్సిటీ అనాలిసిస్. ఇన్ ద టైం కాంప్లెక్సిటీ అనాలిసిస్ ఆల్సో వీ హ్యావ్ ఏ time complexity analysis. In this time complexity analysis we have a different cases అండి. మీకు తెలుసు డిఫరెంట్ కేసెస్ ఏమేమి ఉంటాయి? బెస్ట్ కేస్ అండ్ ఆల్సో వర్స్ట్ కేస్ అండ్ యావరేజ్ కేస్. సో ఈ మొత్తం సబ్జెక్ట్ లో అగైన్ గేట్ లో ఈ ప్రాబ్లం లేకుండా కూడా ఉండదండి. ఈ టైప్ ఆఫ్ ప్రాబ్లం ఒకటి గ్యారంటీ. ఎనీ ప్రాబ్లం స్టేట్మెంట్, దే విల్ గివ్ యూ ప్రాబ్లం స్టేట్మెంట్ ఆర్ దే విల్ గివ్ యూ ఎగ్జిస్టింగ్ ప్రాబ్లమ్స్ అండ్ దే విల్ ఆస్క్ యూ what is the best case time complexity or worst case time complexity or average case time complexity. ఆర్ వర్స్ట్ కేస్లోనే వాట్ ఇస్ ద మినిమం వర్స్ట్ కేస్, వాట్ ఇస్ ద మాక్సిమం వర్స్ట్ కేస్, ఇలా చాలా ఉంటాయండి. ప్రాబ్లమ్ని ఎనలైజ్ చేయడం అనేది చాలా చాలా ఇంపార్టెంట్. అందుకే ఈ డిజైన్, యాక్చువల్గా డిజైన్ అనాలసిస్ అండ్ అల్గారిథం, డిజైన్ అనాలిసిస్ ఆఫ్ అల్గారిథమ్స్ అంటారు. అంటే వీ నీడ్ టు డిజైన్ అండ్ అనలైజ్, అండ్ వీ నీడ్ టు అనలైజ్ algorithms. So that's why the subject is DA subject అంటాం, DAA, design analysis of algorithms. So in order to analyze, we have a time complexities are best case and worst case and average case time complexities. In this average case, worst case and best case time complexity, I am going to explain what is the best case, worst case time complexities of by taking some example problems so that you will understand very clearly. I will take some example problems, then I will explain what is the best case, worst case time complexities. Let us take one simple problem. సో మనకి నెక్స్ట్ ఈ యావరేజ్ కేస్ టైం కాంప్లెక్సిటీ ఇవన్నీలో కంటే నెక్స్ట్ మనకి చాలా ప్రాబ్లమ్స్ ఉంటాయండి. వీటిలో సర్చింగ్ అండ్ సార్టింగ్ అల్గారిథమ్స్ ఉంటాయండి. ఫస్ట్ మనకి సర్చింగ్ అండ్ సార్టింగ్ అల్గారిథమ్స్ ఉంటాయి, సర్చింగ్ యాజ్ వెల్ యాజ్ సార్టింగ్. సో let me explain first by using, let us take one list of elements. In this list of elements, we have a linear search as well as binary search and different searching manner. Now let me explain you simple searching technique. Simple searching technique. So let me explain this. You have some values 7, 9, 6, 5, some 10, 15, and 2. So we have a set of elements. Now we have a set of elements. How many elements are there? It is some list of elements 1, 2, 3, 4, 5, 6, 7. There are 7 elements are there. Now I want to find out first, I want to find out element. I want to search an element. I want to search an element. I just want to search element, search element 10 and how many attempts I will get the 10 and so first I will go for the this position. Now is the 7 is equal to 10? No. Now again I will go for the next position, and can I say that this 10 is equal to 9? No. Again I will go for the next one. So is 10 is equal to 6? No. Again I will go for the 5. So will search it. Is 5 equal to 10? No. Now I will go for the 10 and I will check you. Yes. Whatever I am searching, my element, key element is equal to 10. So that means the element is found. So how many comparisons are required, Andy? How many comparisons it has taken? 1, 2, 3, 4, 5 comparisons. In order to search an element 10, it takes number of comparisons. Number of comparisons. Number of comparisons are how many? Number of comparisons are 5. Suppose if I want to search an element, I want to search an element only 7. I want to search an element 7. Now you tell me how much time it will take. Just number of comparisons are how many? In the first attempt. So whatever I want to element search 7, yes, in the starting element I have found. So it is what? Number of comparisons. Number of comparisons required is number of comparisons required to search an element to search element 7 is only 1. Yes or no? So that means in this searching, so if I want to search in some element, it is taking this is taking 5 comparisons. Now if I want to search 7, it is taking 1. Suppose if I want to search, let us take 2. So how many comparisons it is taking, Andy? So number of comparisons it will, how many? 7 comparisons. 7 comparisons is going to take. Now this is what? Now with the same problem, in the same problem, so number of comparisons, if I want to search is 7, it is taking only 1 comparison. If I want to search 2, it is taking in general, how many? 7. 7 and 10 and 8. Number of elements are n. So in general, it is taking n. In general, it is taking 1. Ante, in the best case, what is the time complexity? What is the time complexity of searching particular element in the best case? That means whatever I want to search the element, if the element is found at the starting position, that is called it as a best case. That is a best case. So the best case time complexity of this problem is at this point of time I'm at order of 1. Order of 1. Order of 1. Sir, what is the worst case time complexity? Best case is order of 1. In general, what is the worst case? Suppose if I have 100 elements in the list, I have 100 elements. So if the element I want to find out is 199 position, then I can say how many comparisons are required in the worst case. Can anyone tell me? What is the time complexity of the worst case? Order of how many? In general, if n elements are present, then I can say order of n. Order of n. Order of n. Similarly, it's average case. Average means maybe it is find out the first position or a second position or a third position or fourth position or fifth position or sixth position. So if you like an average case, if you sum up with all those things, you will get, if you have a 1 plus 2 plus 3 and so on. So that means an average case may be anything in middle. Yeah, 9 is average case, 6 is an average case, or 5 is an average case, like this. So, but best case is we are finding only first element, and worst case last element, or maybe worst case, maybe the element you are searching for, it is not there in the list also. It is not there in the list also. At that time also, it is taking order of n. It is taking order of 1. సో ఇది ఏదైనా తీసుకోవచ్చండి. ఆర్డర్ ఆఫ్ వన్ అంటే బిగ్ ఓ నోటేషన్ రాయొచ్చు, టీటా నోటేషన్ రాయొచ్చు, స్మాల్ ఓ రాయొచ్చు. ఇక్కడ ఏం పెద్ద దీనికి అంత ఇంపార్టెన్స్ ఉండదు. ఓకే, బట్ వీఆర్ జస్ట్ ఫోకసింగ్ ఆన్ ఓన్లీ బెస్ట్ కేస్, వర్స్ట్ కేస్, సో అండ్ యావరేజ్ కేస్. ఓకే, యావరేజ్ కేస్ is some n by 2 like this. Okay, this is what average case and best case. Average case. I hope you understand. What is the best case time complexity and what is the worst case time complexity? If it is in there in the middle, that is called average case. Okay. So you can try to write down. Next. So this is just searching. Searching sorting techniques ఉంటాయండి. ఓకే, సో ఇది లీనియర్ సెర్చ్ అంటాం. ఏమంటాం దీన్ని నౌ ఇన్ టెక్నికల్ యూ కెన్ సే దిస్ ఇస్ లీనియర్ సెర్చ్. Linear search. Maybe the elements you can store in array format or whatever, maybe, you know, list format, whatever format. Okay, this is a linear search. Okay, sir. Now, if I want to search, this is a linear search. Linear search. Next, binary search. Suppose if I want to binary search. అర్థమైందా అండి? Binary search. Let me explain binary search. Binary search tree. Suppose the elements, suppose we have some elements are there. I want to store in the elements in the binary search format. Suppose that 10. We have a 10, 6, and 15. We have a 3, 7, 12, 17. So let me write. So first of all, what is binary search? Okay. So binary search tree. Suppose these elements I am storing in the form of binary search tree. So let me explain this. Also, what's the time complexity and how to find out the time complexities. That is my intention. Finding out the time complexities are very, very, very important for any problem statement. So basically, what is binary search tree, Andy? Basically, binary search tree యొక్క డెఫినేషన్ ఏంటి తెలుసా తెలీదా మీకు? సో తెలియకపోతే నేను చెప్తా. Binary search tree. So when we are storing the elements, the left hand side elements, so the root element is there, and whatever the left hand side element should be lesser than the root element, and if you are making a right chain, so then greater than the root node. Greater than the root node. That is the condition you have to follow while you are doing binary search tree. Okay. So now let me first write. What is the first initial element? ఇది బైనరీ సర్చ్ ట్రీ అండ్ ఎలిమెంట్స్ కూడా ఇలా ఇస్తాడండి, ఒక్కసారి ఇన్సర్షన్ డిలీషన్ కూడా ఇస్తారు. ఓకే, సో దట్స్ వై యూ హ్యావ్ టు careful enough. We have many problems in this. So 10, in this 10, I have first 10 element is there, and from the 10, what is the left hand side element? So next element it came 6. Is 6 is less than 10 or greater than 10? 6 is less than 10. So that means where should I place that? 6, it should be placed on the left hand side. So 10, 10 left hand side. So this is 6. It is 6 is present. Now again next element is 15. Now is 15 element is greater than 10 or less than 10? It should be a greater than 10. So where should I place? So I have to place 10 is greater than here. What is the element? Next element is 15. 15. Suppose next element 3 came. So element 3 came means, so whether it is a less than 10, yes, less than 10, and less than 10 and also 6. Is it greater than 6 or less than 6? 3, less than 6 only. So where should I place this one? 6 is less, 3 is less than 6. So I can place here. I can place 3. Next, the element 7 came. The element 7 came. 7 means the is it less than 10 or greater than 10? It is a less than 10. When it is a less than 10, so now again you have to check for the, is it greater than 6 or less than 6? It is a greater than 6. So the element 7 you have to place here. The element you have to place. It is 7. Now again now again 15. So after 15, now again 7 is there. Now where we are at 12. 12 means, 12 means, is it greater than 10 or less than 10? It's a greater than 10. Greater than 10 and again 15. Next to 12 is less than 15 or greater than 15? It's a less than 15. Less than 15 means you have to left hand side. So less than 15, it is 15 is, here it is 12. And now it is, last element is 17. Now 17. 17 is here. 15 is, 17 is greater than 10 as well as greater than 15. So I will place here 7. I will place here 7. This is binary search tree. This is called binary search tree. So previously we have searched linear search. So now in this binary search tree, now tell me, so I want to search a particular element. I want to search in a particular element in the binary search. So you tell me now, what is the best case time complexity and what is the worst case time complexity? What is the best case and what is the worst case time complexity? Can you please answer? Suppose anyway, best case chapandi. I want the best case. What is the best case time complexity of binary search tree? I want first best case. Can anyone please give me answer? What is the best case time complexity of your binary search tree? Answers చెప్పాలండి compulsory. What is the best case time complexity? So best case is, suppose if I want to search an element 10, maybe. If I want to search an element 10. So 10 is present in where, Andy? Directly at the root position, right? At the root node. So if I found at the root node, how many comparisons I require? Only comparison. So the best case time complexity of a binary search tree is definitely it is a order of 1. Order of 1. That means this is the best case time complexity. So whatever I want to search an element, this is at found at the first. Now, what is the worst case time complexity, Andy? Can you please tell me what is worst case time complexity for this tree? At least tell me for this tree. Worst case time. What is the worst case time, Tiffany? Suppose ఇందులో worst case అంటే ఏంటండి? Worst case అంటే suppose I want to search an element, maybe I want to search an element 3. So how many comparisons? First 10, next 6, so next 3. Like this I have to go, right? So that means 3 means ఎలా చెక్ చేస్తాము? Is 3 is less than 10 or right hands greater than 10? 3 is definitely left. That means I cannot go right hand side. I have to go back only left hand side only, because I want to search an element 3. The 3 should be present on the left hand side only. Next, that is a one comparison. Now it is not a root node. Now is it greater or lesser value? So now it will come to here position. Is it a 6 equal to 3? No. If it is no, then we have to search element 3. So the element 3 is present greater than 6 or lesser than the 6. It should be lesser than the 6. So the element is 3. So now 3. Now what element you need to find out? 3. Yes, the element is matched. So I want to search an element 3 only. So maximum how many comparisons are required, Andy? 3 comparisons only. 3 comparisons. 3 comparisons అంటే ఏంటండి? అలాగే నెక్స్ట్ సపోజ్ ఐ వాంట్ టు 12. 12 సెర్చ్ చేయాలంటే చూడండి, ఫస్ట్ కంపారిజన్, ఈజ్ ఇట్ ఈక్వల్ టు రూట్ నోడ్? నో, దిస్ ఇస్ వన్ కంపారిజన్. నౌ 12 ఈస్ గ్రేటర్ దాన్ root node, greater than 10 or lesser than the 10? It should be a greater than 10 only. Now I come to here this position, and again I will check here. The whatever I want to search an element at 12, is a 12 is lesser than 15 or greater than the 15? It should be a lesser than 15 only. So where should I check here? I should check here left hand side of the 15. So that means I will search here. Now I will search here, is 15 is a 12 is equal to here this 12? Yes. So the element is at found at the final position. That means last position. So that means how many maximum comparisons? First 10, next 15, next 12. Only 3 comparisons are required. That means in general, can anyone tell me for this tree, what is the worst case time complexity? What is the worst case time complexity of the binary search? Chapalandi, what is the worst case time complexity of this binary search? So that means worst case time complexity of this one is, can I say height of the binary tree? Height of the height of the tree? Yes or no? Height of the tree. So here height of the tree is maximum I can go in the height. So if the height of the tree is 10, then maximum comparisons will be required is only 10. Like this, it depends on height of the binary tree. Height of the binary source tree. Height of the tree. So what is the height of this tree, Andy? 3. So in general, 3 means the worst case time complexity is log 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 n based. So in general, I can say that worst case time complexity is log n. So I can say that the worst case time complexity is order of log n. So this is what of log n. So this is a worst case and this is a best case. This is the best case and worst case. The average case is like a 6 or like a 3 like this. This is also a log n in general. Now tell me, suppose ఈ ట్రీలో ఇలా ఉంది కాబట్టి ఓకేనండి. Now I will go for one more tree. Suppose now I will go for one more tree. Let me draw one more tree. So you try to see here. 5, 6, 8, 9, 10, 15. So 15 plus 18. So these are the elements are there. Try to arrange in the form of binary search tree. All of you. Please try to arrange it, this into a binary search tree. Please try to construct the binary search tree. Binary search tree ante emundi. So if the root node we need to take first, then you have to compare root node with the next element. So if it is a lesser than the root node, so go for the left hand side. If it is a greater than the root, you have to go for the right hand side part. So now tell me. So first 5 అండి. Answers ఇవ్వాలి నాకు. Okay. What is the first 5? Now in this 5, you check here. You check here. So the 5 is a root node. 5 is a root node. Now I'm writing here. Okay. So here, let me draw here. 5 is the first root node. And next element is what? 6 and 6 is less than 5 or greater than 5. The 6 is 6 is greater. 5 is greater than. So here 6 is greater than 5. So you have to give the right hand side. Next element ఏంటండి? 8 is greater or less than the 6. It is a greater than 5 as well as greater than 6. So where you have to place? You have to place here. You have to place directly is greater than, here it is 7. 7. Okay. 7 or 8. Sorry. Okay. 8. Next element. Next element is what? 9 and next 9 and 10. It is also 9. 9 means it's a greater than 8 only. It's a greater than 8. So I have to draw like this. 9 and again 10 and 10 and it greater than, it should be greater than 9. So it should be greater than 9. So be greater than 10. అలాగే now 10 అండి 10 మిన్న 10 అయిపోయింది నెక్స్ట్ 15 5 6 8 9 10 next one is 15 15 means it should be greater than 10 only, greater than 10. So greater than 10, so where should I place? It's a 15 like this 15 and the next one is 18 18 also it is a greater than 15, it's a greater than. So like this, what is the height of the binary tree? Height of the binary tree becomes, so almost number of elements present in that is the height of the binary tree also n in this case. Now in this case, tell me what is the best case? Now for this tree, what is the best case time complexity? What is the best case? What is the best case time complexity? So best case of the time complexity for this tree is, anyhow, if it is find out if I want to search in a 5, if it is present in the root level, then we can say that is the best case. So I can say without worrying about this, I can say that it is order of, it is order of 1. Okay. Suppose if I want worst case time complexity. Now tell me, can anyone, what is the worst case time complexity of this worst case time complexity of this binary search tree? Worst case time complexity. Tell me, what is the worst case time complexity of this one? In general, Chepali, what is the worst case time complexity of this one? I already given height of the binary tree. What is the height of the binary tree? Binary search tree. For this one, what is the height of the binary search tree? Is equal to what? Is equal to what? Order of n. Order of n, because n elements are present. So now here height of the binary tree is almost in this case n. So the worst case time complexity of this binary search tree is n. But in this balanced binary search tree, this is called as a balanced binary search tree. Balanced binary search tree. So the left hand side elements and right hand side elements are equally distributed. This is a balanced binary search tree. Balanced binary search tree. This is unbalanced binary search tree. You see here. So this is almost, it is taking order of n. That means in the worst case time complexities also we have two things. In binary search tree, the worst case time complexities also we have two things. What are the things? The minimum worst case time complexity, minimum worst case time complexity, minimum worst case time complexity is, as well as maximum worst case time complexity. This is very important for the GATE exam. Most of the people will confuse. Worst case also, there is a one case. In the worst case also, we have some special. So maximum worst case time complexity. Maximum worst case time complexity is maximum worst case time complexity. So what is the minimum worst case time complexity? Is log n, order of log n. Whether you can use anything, Andy. Whether you can use data notation, whether you can use a big O notation, whether you can use a small O notation, there is no issue. Okay. So just this is I'm just in general writing order. I'm just writing only at this point of time order of the log, order of log n. The minimum minimum worst case time complexity. ఇంకా కొంచెం క్లియర్ ఒక్కసారి ఏమడతారంటే వాట్ ఈస్ the best case of worst case time complexity? So that means in the worst case, what is the best? సో చాలా ట్రిక్కీగా అడుగుతాడు. సో మీకు ఒక్కసారి కాన్సెప్ట్ తెలిసిందంటే ఈజీగా. అందుకే మినిమం వర్స్ట్ కేస్ టైం కాంప్లెక్సిటీ ఆఫ్ దిస్ వన్ ఈస్ log n and the maximum worst case time complexity is order of n. So order of n. This is what entandi order of n. So this is a very important for the gate. Okay. Not only this problem, like this, they can ask, for any problem statement. For any problem statement, they can ask like this. What is the minimum worst case time complexity and what is the maximum worst case time complexity? Not only worst case. Most of the people will, they will study up to what is the best case or what is the worst case. In the worst case also, what is the minimum worst case? What is the maximum worst case again? So that is the beauty of this, these problems. I hope you understand this concept. Like this is a searching. And similarly, we have a sorting concepts also. So we have different searching as well as a sorting techniques. And we have a different sorting techniques are there. So in the sorting techniques, so first, what you need to focus? You need to focus the problem solving approach and the problem statement. Suppose in this also, select in the searching also, what you need to learn? You need to learn, how to, what is the way of binary search tree and how to enter the elements and how to delete the elements also is there. I think in the data structure subject or something, you will find that how to insert element, how to delete element. If I delete some particular element, what happens also is there. Okay, that is covered in the data structures actually. So, but here we are just focusing on time complexities. That's why I just focused. And as a basic, what is a binary search tree and how to construct the binary search tree for a given elements. This is for our subject.
నేను తీసుకురాను రా.
So this is something about binary search trees. And if you have any questions, you please try to answer it. You please try to ask some questions from your side. This is the best case time complexities. And in the next class, we can start some sorting techniques also. Sorting techniques, and we have a different problem solving approaches are there. And we have to find out for that every problem, we need to find out the time complexity. ఇక్కడ మీకు లాస్ట్ లో అట్లీస్ట్ గేట్ ఎవరైనా ప్రిపేర్ అయ్యే ఇప్పుడు రాస్తున్న వాళ్ళు ఎవరైనా ఉంటే ఒకవేళ ఇయర్ అట్లీస్ట్ మీరు ఏం ఫోకస్ చేయాలంటే అట్లీస్ట్ యూ ట్రై టు రైట్ డౌన్ ఆల్ ద వాట్ ఆర్ ద డిఫరెంట్ సర్చింగ్ టెక్నిక్స్, వాట్ ఆర్ ద డిఫరెంట్ సార్టింగ్ టెక్నిక్స్, అండ్ ట్రై టు రైట్ డౌన్ అట్లీస్ట్ what is the best case time complexity, what is the worst case time complexity of every problem. So in the tomorrow class, at least I will try to, explain what are the different time complexities of bubble sort. Like we have a different sorting techniques are there, and all the sorting techniques I will try to explain for based on our time requirements. I will try to explain. Now from your side, if you have any questions, you please keep in chat box. I will try to answer it. So what is what? Worst case time complexity of linear search. Now what we have learned? Now you have to remember finally what you have to remember. First, at least you have to remember this. In linear search, what is in linear search, what is the worst case time complexity? Right. What is the worst case? What is the worst case? And here, what is the average case? Average case. And next, what is the best case? చెప్పండి. In the linear search, what is the worst case? Worst case time complexity is order of n. And average case also order of n by 2. Suppose n by 2 ante n, it becomes n only. So next, best case is 1. Best case is 1. Because what is the best case? If the whatever the searching element, it is present in the root node, that is the best case. Worst case means whether it is present in the last or it is not found. That is the worst case. Average case means it may be in the middle of this all. That's why average case. Next, coming to binary search. So binary search. So the worst case. ఈ worst case లో కూడా 2 cases చెప్పాను binary search లో. మళ్ళీ binary search tree, I can say, not only binary search tree. So in this, I have 2 cases in the worst case also. In the worst case also, I have given 2 cases. Minimum worst case as well as maximum worst case. If it minimum worst case, if it is a minimum worst case, log n. If it is a maximum worst case, it is n. It is a maximum worst case, it is n. And what is the average case? The average case is also, we can say, similar. It is a log n. So best case is, what is the best case? Anyhow. So if element is found at an starting position, that may be anyway, it will be the best case. If it is the root node. then I can find in a one atom. So this is how, we have a best cases, worst case, and average cases of a linear as well as a binary search. So for exam point of view, this is very, very important. Now, if you have any questions, please ask till now. Tomorrow we will solve some more problems as well as, and we will see some more concepts. Tell me, if anyone is having any doubts, you please keep in chat box. Otherwise, we will try to close the session. We have, I'm giving 2 minutes. If you have any questions, you please, keep in chat box or you can ask. No issue. Okay. So we will see in the next class. So now today we can wind up the session. Can we close the session? Okay, right.
మా లెఫ్ట్ అయిపోండి, క్లాస్ కంప్లీట్ అయిపోయింది. Request all the students leave the meet immediately.